This is an overview video for College Trigonometry version 3 by Stitz and Ziegler, 10.5 Graphs of the Trigonometric Functions. This video covers graphs of the tangent and cotangent functions. Looking at the graph of y equals tangent x, we're going to use our unit circle information and the fact that tangent x is sine x over cosine x. Sine x is the second part of the point and cosine x is the first. So for 0, tangent is sine over cosine 0 over 1. For 0, tangent's 0. For pi halves, tangent is 1 over 0. That's undefined. For pi, tangent is 0 over negative 1, which is 0. For 3 pi halves, tangent is negative 1 over 0, which is undefined. And again at 2 pi, tangent is 0 over 1, which is 0. It is also useful to get some extra values, and these are convenient for tangent. These are the pi fourths, and let me remind you all students take calculus. At pi fourths, the x value and the y value are equal, so sine and cosine would both be square root of 2 over 2, but they're both equal, so tangent's 1. So we would have 1, tangent's positive here, 1, negative here, negative 1, positive 1, negative 1. And then we see pi fourths 1, 3 pi fourths negative 1, 5 pi fourths 1, 7 pi fourths negative 1. These give us some extra points, but let us see that tangent is an increasing function over its domain. Always increasing. And the asymptotes are everywhere the tangent was undefined. Those are all the pi halves or 3 pi halves. Those are the same values as the secant function because both tangent and secant have a divide by cosine in it. So everywhere cosine equals 0, tangent is undefined and secant is also undefined. So tangent shares asymptotes with secant because of the cosine in the denominator. We are looking at 2 full periods. Tangent repeats itself from pi halves to 3 pi halves. After pi, it then repeats itself and repeats itself. This comes about partly because of all students take calculus. Tangent's positive, then negative. Then, after only pi, it repeats positive, then negative. So tangent repeats itself after a period of pi. Whereas for sine and cosine, for sine, positive, positive, negative, negative, it takes a full circle before it repeats positive, positive, negative, negative. And for cosine, positive, negative, negative, positive, positive, negative, negative, positive, it takes a full 2 pi before it repeats. But tangent, positive, negative, only takes pi. So period of pi, asymptotes at 3 pi halves, 5 pi halves, odd pi halves, and it's an increasing function. For the graph of y equals cotangent x, we look at the fact that cotangent x equals cosine x over sine x. So for x equals 0, cosine is the first one, y value is sine, so we have 1 over 0 for cotangent, cosine over sine. 1 over 0 is undefined. At pi halves, we have 0 over 1, which is 0. At pi, we have negative 1 over 0, undefined. At 3 pi halves, we have 0 over negative 1, that's 0. And at 2 pi, we have 1 over 0, again undefined. If we include the points at the pi fourths, which are convenient for tangent and cotangent, we have the same value for sine and cosine there, so tangent would be 1. Cotangent would be 1 as well. Cotangent's 1 here, negative 1, 1, negative 1, just like the sine was. Okay, if we look at these on the graph, we notice our vertical asymptotes are at 0 and pi and 2 pi. All the even number or all the pi's, the whole units of pi's, 0 pi, 2 pi, etc. we can see two full periods. So we see that a period for cotangent is the same as a period for tangent. It's pi. However, this function is different from tangent because it's always decreasing. That gives you an overview of the cotangent function. To summarize the information about tangent and cotangent, we look at this theorem. Notice the domain for tangent is all the spots where cosine is non-zero. These are all the values where cosine is 0, so the domain is everything but those. The range is all real numbers. It's continuous and smooth on its domain. It's odd and has a period of pi. The cotangent function has the domain all real numbers except where sine equals 0, which are all of the k-pi's. Those are your vertical asymptotes. All real number range, continuous and smooth. It's also odd, and the period's also pi. The cotangent, because it's divided by sine, shares the same asymptotes as the cosecant that's divided by sine. Looking at a specific example, again we see the basic process this book uses. However, we have a little bit different x values to use. The key points for the regular tangent are negative pi halves is an asymptote, negative pi fourths, 0, pi fourths, and pi halves is an asymptote. Those are the x value of the key points. Now they're not all points, there's some asymptotes in there, but the key values, the x values. We set the inside of the trig function equal to these key values and solve for x, giving us new x values. We then plug those x values into the function to find the y values. These give us our new asymptotes and our new key points, and that's how you graph the tangent. The only difference from the sine, cosine, secant, cosecant are these values are different for tangent, and they're also different for cotangent. Cotangent values would be 0, pi fourths, pi halves, 3 pi fourths, and pi, and you'll see that when you see the examples in the book. So they have a different set of startup x values, but after that you set the inside equal to that, solve for x, plug it in, graph, same overall process. Excellent. The period of this one we can see goes from negative pi to pi. That would be a period of 2 pi.